So you know that you can label this information. Okay, so this whole length here is 13. And we know the radii, so let's label those. So what do we have to do in order to label a radius? Draw it out first, right? So if we connect these and form our radii, just like we did in the other problem. So when you look at this, the radius and the tangent will intersect at right angles. Okay, now here's the trick on this, and it's a little bit tricky, but once you see it, it should be able to make sense, and it can be extended to any problem like this. And that is, since we have this right angle right here, and these two segments, the radii, the the radii in each of these are perpendicular or parallel to each other. What's going to happen if I draw in a line straight from this vertex or this point that's perpendicular to this other line? What type of figure did I just create here? I created a rectangle, right? So I'm going to use the idea that if I create this rectangle right here, what do you know about the opposite sides of any parallelogram, including a rectangle? The opposite sides are equal, right? So I know that this length is equal to this length. So if I can find this measure right here, then I know what my common external tangent is. Again, the common external tangent does not pass through that imaginary line connecting the centers. Okay, so let's label the pieces. We know our radius on the small circle is 3, and the radius of the large circle is 8. Well, again, what do we know about opposite sides of a rectangle? So if this segment is 3, what does this portion here have to be? Also 3. So what's left for this remaining portion? 5. Okay, and what angle is going to be formed right here? So now, if I look at the figure that's formed by the two centers plus this intersection, what type of a shape am I looking at? And more specifically, what type of triangle? A right triangle. I have a leg of 5, a hypotenuse of 13. What's the other leg going to be? 12. So if that's 12, then what's the length of that common external tangent? 12. Okay. So once again, they won't always fit into these nice easy numbers. I wanted to take some examples that helped reinforce the special triangles and the common triples. Okay, so this is a 5, 12, 13 common triple. If you don't remember that, you can still use Pythagorean theorem, 13 squared minus 5 squared, square root that, and you'll get your remaining side.